This is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to continue with the lecture series Notion of an Algorithm. So let's start with a recap of what is an algorithm and its characteristics. So we all know an algorithm, it is a sequence, it is a finite set of instructions that is followed which accomplishes a particular task. In addition to this, all algorithms must satisfy the following criteria. That is, we have already seen the 5 characteristics of an algorithm. So the first characteristic of an algorithm is the input. So for input, it should have 0 or more quantities or extremely upright. The next one is output. So at least one quantity should be produced. At least the output, for an output at least one should be produced. The third characteristic would be definiteness. So here in definiteness of an algorithm, each and every instruction of an algorithm, each and every step of an algorithm should be very clear, and it also should be unambiguous. So we know what is unambiguous. Unambiguous represents only a single meaning for the particular step of instruction. So it should be very clear, precise and unambiguous. The fourth point would be finiteness. Finiteness is nothing but if the instruction of an algorithm is traced, then for all the cases of the algorithm, it must terminate after a finite number of steps. So that is called finiteness, nothing but it should end at a finite number of steps. The last criterion or the characteristic of an algorithm is effectiveness. So effectiveness represents for each and every instruction it should be very basic, and it also should end in a short period of time. So these are the characteristics of an algorithm. Let us see the notion of an algorithm. So the notion of an algorithm is represented in the following diagram. So the first point in the notion of an algorithm, the first point would be the non-ambiguity requirement for each step of an algorithm cannot be compromised. So the first point is the non-ambiguity is not compromised. Then the second one is the range of inputs for which an algorithm is worked has to be specified carefully. Third one is the same algorithm can be represented in several different ways. Fourth point would be there may exist several algorithms for solving the similar program. For example, let us take a sorting. So we'll have different kinds of sorting. The last point for the notion of an algorithm is algorithms for the same problem can be based on very different ideas and can be solved the problem with grammatically different speeds. So this is about the notion of an algorithm. So in simpler way, if a problem is given, when we are going to write an algorithm, it would be fed to the computer using some inputs, and then the computer will give the desired output. So this is the notion of an algorithm. So in notion of an algorithm, there are different types of algorithm. So to write an algorithm, we have a different thing. So let us see one by one how to write an algorithm. So steps for writing an algorithm. So as we all know, an algorithm is a concept base. It is a procedure. It has 2 parts. The first part is head and the second part is the body. So in the head section should always contain the keyword algorithm and the name of algorithm with the parameter list. For example, if I am going to write an algorithm, so for example, let us have a syntax algorithm, the name of the algorithm, then the parameter list P1, P2, etc. For example, if I am going to find the GCD of an integer m and n, then it should be algorithm GCD m comma n. So this is the first step in writing an algorithm. So the head section should also have the following. It should have the keyword algorithm, and it should also contains the following parameter list. So the first one should be the problem description, why I am writing this algorithm. The next one, the possible input cases, and the third one would be the output phase. And the next step in writing an algorithm is, in the body of the algorithm, various programming constructs like if, for, while and some statements like assignments can be used. The compound statements end of n while respectively can also be used. Comment should be always written using the slash in the beginning. The identifier should begin by a letter and not by the digit. Random or the Boolean operators, true, false, logical operators and relational operators can also be used in an algorithm. Input and output can be done using read and write. In array, if then else condition, branch and loop can also be used in an algorithm. So these are the steps in writing the algorithm. The main thing is keyword should be written, problem description, input, output. Then the body of the algorithm should contain any constructs if, for, while, etc. So these are the procedure of writing an algorithm. So let us consider the types of algorithm. So there are commonly three ways in writing an algorithm. The one is Euclid's, consecutive integer checking, middle school procedure. Let's see one by one. Euclid's algorithm. So Euclid's algorithm for computing GCD of m comma n can be written in simple way. Step 1, if n is equal to 0, return the value of m as the answer and stop. Otherwise, go to step 2. Step 2, divide m by 1 and assign the value of the remainder to r. Step 3, assign the value of n to m and the value of r to n. Go to step 1. So this is Euclid's algorithm. The next thing is consecutive integer checking algorithm. So step 1, in consecutive integer checking algorithm for GCD of m comma n, the step 1 is it should assign the value of minimum m comma n to 1. Step 2, divide m by t. If the remainder is 0, go to step 3, else otherwise go to step 4. Step 3, divide n by t. If the remainder is 0, return t and stop. Otherwise, move to step 4. Step 4, decrease t by 1. Decrement t by 1 and then go to step 2. So this is about consecutive integer checking algorithm. The same thing can also be written in the middle school procedure. For computing GCD of m comma n, so step 1 here would be you have to find the factors of m. Step 2, find the prime factors of n. Step 3, identify all the common factors in the two prime expansions found in step 1 and step 2. In step 4, it should compute the product of all the common factors and return it at the greatest common divisor of the numbers given.